Here's another example of the goodness of fit test. So in that first one, we just wanted to know, are the different categories equally represented? In other words, are the frequencies the same for each category statistically? In this example, we want to know if the frequencies that we observed across the different categories are the same as those in some other distribution. Okay? So this is the same example as I gave in the book. So if you didn't understand it in the book, hopefully my explanation here will help you. And if you haven't yet read the book, well, and you don't understand my explanation here, then maybe reading the book will help. All right? So hopefully either way, you will get it, either through reading the book or listening to me here. All right. Let's pretend our question happens to be, are GRE scores at your university distributed the same way as they are nationally, as reported by the NGTA, National GRE Testing Agency? I don't actually know if that exists. I made it up because I like the acronym NGTA. I just thought it sounded kind of cool. Don't go looking for it. It may or may not exist, okay? And for those of you who don't know, the GRE is a standardized test that some schools require to get into graduate school, okay? The graduate record exam. So again, you have, let's say everybody at your school takes the GRE, and you want to know if their scores, which we're going to group into categories, whether or not those scores are distributed the same way as they are across the country nationally. So you're going to just observe 200 people. By observing, it means you're going to go up to them and you're going to say, hey, what was your GRE score? And you're going to use that information to put them in a category. Because remember, your variable, and you only have one, your variable has categories. They're not continuous variables, they're categorical. All right, so the categories for GRE scores are below 500, 500 to 599, 600 to 699, and 700 plus. All right, so those are your 4 different categories. Notice how they do not overlap. Let's say it's impossible to have a score that is decimal. So it goes up in whole numbers. So that means you either have 599 or you have 600. It's impossible to get in between. So these would all be non-overlapping categories, and we satisfy the criteria that there has to be at least 2, right? Here we have 4, so we have that. And we don't have too many. Because remember what I said about having too many categories? You will probably violate the assumption that all of your expected frequencies are at least 5 for every category. All right, so here are the different categories. And again, as you approach each student, you're just going to put them into one of these categories, right? Because they're going to tell you the score, and then you're just going to say, okay, you're in this category or that one, etc. Okay? Notice how they all add up to 200 because you surveyed 200 people, and these are the observed frequencies. So these are the actual data. Now, you go online and you find out what the percentages are for the NGTA, so the national data. And on their website, they claim that 15% of students nationally fall into this lowest category, below 500, followed by 50% in this category, then 30%, and then 5%. Okay? Now, you might be tempted to say, okay, so we're going to compare 16 to 15 and 70 to 50, etc. But that would be wrong, because these numbers here in this first row, these are frequencies, right? And then what are these? These are percentages. Now, they could be frequencies if you said, well, 15 out of 100, right? Because 15 out of 100 is a percent. but 15 would also be the frequency. It's just the frequency if you assume you have 100 people, all right? Up here, these are the number of people out of 200, not out of 100, out of 200. So if you compare the frequencies in this row to the row here down beneath, that would be like comparing apples to oranges. You've got to either convert all of these numbers here to a percentage, and then you're comparing percentages to percentages. That's okay, apples to apples. Or you've got to take these numbers here, the percentages, and convert them to frequencies. And then you're comparing frequencies to frequencies. And that's, again, comparing apples to apples. Okay? The only time really that you wouldn't have to convert anything is, let's say, if you sampled 100 people. If you sampled 100 people, and let's just say 16 were in this category, well, that's the same thing as saying 16%. And then you could compare the 16 to the 50. All right, so how do we go from percentages to frequencies or frequencies to percentages? Some people find it easier to go, one way or the other way. But I'll show you both ways, just, cover all the bases. Right here, what I've done in this last row is I've taken the NGTA data, and instead of using percents, I converted it to a frequency. All right. So basically what I said is, okay, that's 15%. That's 15 out of 100. What would be the equivalent out of 200? Now, you could look at this two ways. You could reason in your head, well, if it's 15 out of 100, then to find out what it is out of 200, just double it, right? 200 is double 100. So 15 becomes 30, 50 becomes 100, 30 becomes 60, and 5 becomes 10, all right? And again, you just doubled these numbers because you went from 100 to 200, all right? But that's not always going to be the case, that you're going to have just a nice number. You can just double it, all right? What if I said this number here wasn't 200, but it was, I don't know, 682, right? Then it becomes not as easy to figure out in your head what the percentages would be, all right? So I'm going to give you the formula just so that you know. So to figure out what should we expect to see if the NGTA data wasn't, let me get rid of that. What would this number, this percentage be if in fact the NGTA data was based at a 200? And I'm using this 200 because we had 200 in our sample. So we want to know, what should 15% of 200 be? Okay, that would give us the expected frequency. So 15% of our total sample size, to get that, you just take 0.15. So you got to convert this to a decimal. So 0.15 times 200. That gives you 30. 0.50 times 200 gives you 100. 0.30 times 200 gives you 60. And this one, be careful, this is not 0.5, this is 0.05 times 200 gives you 10. Okay, so if you want to convert percentages to frequencies, you have to take these percentages, convert them to a decimal, and then multiply that by your sample size. And that will give you the corresponding frequency for each and every cell, right? Each and every category. And then you can compare frequencies to frequencies. Now that's one option. Another option is to say, well, these are frequencies up here. Let me just convert them to percentages. So what is 16 as a percent? So to figure that out, you take your frequency, divide by your total n, and then multiply by 100. So it's 16 divided by 200 multiplied by 100, because you're going to get a decimal. All right. And so you need to go back to percentages. So you multiply by 100. So this would be 70 divided by 200. And then you get a decimal answer, and then multiply by 100 to get a percentage. So, whether you decide to take your observed frequencies and convert them to percents, or take your expected percent data and convert them to frequencies, that's a personal choice. Just make sure that when you compare observed frequencies to expected frequencies, they're either both frequencies or they're both percentages. Okay? And that's what this is meant to remind you of. Make sure you're comparing apples to apples or oranges to oranges. So you either compare frequencies to frequencies or percent to percent.